What if I told you there is now an AI that can hunt down security bugs, test real exploits, and even fix them automatically all on its own? Yeah, you heard that right. No human hacker, no team of analysts, just pure AI acting like a full-fledged security researcher. And guess who built it? OpenAI. They have just unveiled something called Aardvark. And honestly, this might be one of the most advanced and game-changing AI tools we have seen this year. Now, before you think, okay, it's probably just another fancy vulnerability scanner, let me stop you right there. This isn't your regular static analysis tool or some GPT plugin running code suggestions. Aardvark is an agentic security researcher, which basically means it can think, reason, and act on its own, just like a real cybersecurity expert would. So in this video, we are going to break it all down, so let's dive in. Before we jump into how Aardvark works, it's important to understand why OpenAI even built something like this in the first place. See, the world runs on code. Every app, website, or AI tool you use, it's all built from millions of lines of code that are constantly changing. And here is the problem. For every 1,000 lines of new code written, there is a chance a small bug or a logic error slips in. And sometimes, the tiny mistakes can become a massive security hole. Now, here is where things get scary. The speed of coding has exploded because of tools like GitHub Copilot, GPT-5, and AI-assisted coding. But security hasn't kept up. Humans simply can't review every single change, every pull request, every dependency update, right? It's like trying to find one wrong wire in a skyscraper full of cables. You can't do it manually anymore, right? In fact, studies show that nearly 80% of vulnerabilities in production code come from logic errors, not from known exploits or malicious intent. Meaning, they are not the kind of bugs you can easily catch with a regular scanner. They are the "oops, I didn't think of that case" type of problems that happen when software behaves unexpectedly. And that's where OpenAI's idea came from. They asked, what if we could train an AI not just to detect patterns, but to actually think like a real security researcher? Like, what if instead of just pointing at a suspicious line of code, it could ask itself, wait, could this function be exploited if someone passes the wrong input? What happens if authentication fails halfway? Basically, what if we could make an AI that doesn't just analyze code but understands it? That's the whole idea behind Aardvark. It's what OpenAI calls an agentic system, which simply means the AI isn't just passively responding to prompts, it can act autonomously. It can plan its own steps, test its own ideas, validate them, and even propose fixes without needing constant human guidance. And for developers watching this part is huge because traditional scanners or fuzzers, they just highlight potential issues like, hey, this looks bad, but they can't tell you why it's bad or how it could be exploited in the real world. Aardvark changes that. It reasons through the logic just like a seasoned security engineer would, and that's what makes it so powerful. Alright, so now that you know why OpenAI built Aardvark, let's actually talk about what it is, because this part is mind-blowing. Well, think of Aardvark like a perfect mix between a senior ethical hacker and a super fast AI lab assistant. It doesn't just scan your code for known issues like a regular tool would, it actually reads your code line by line, understands what it's doing, and tests it to see how it behaves. Now, here is where it gets really interesting. Aardvark works in 4 main stages, and once you understand these, you will see why this system is so far ahead of anything else out there. Talking about the stage 1 is the scan and detect. Aardvark constantly keeps an eye on your code base. It watches commits, pull requests, or any new changes pushed into a repository. The moment it notices something unusual, like a pattern that looks risky or a function that's been rewritten in a suspicious way, it flags it. Now, here is a quick tip for developers. If you are managing big projects, this kind of constant monitoring can be a game changer. You can integrate similar systems into your CI/CD pipeline so bugs are caught the moment they are introduced, not months later when they turn into vulnerabilities. Now comes the stage 2, reason and hypothesis. This is where GPT-5's intelligence kicks in. Unlike normal scanners that say, hey, this might be bad, Aardvark actually thinks about it. It starts asking questions to itself like, could someone exploit this function if they said unexpected data? Or what if this API doesn't properly validate input? That's what we mean when we say it reasons. It doesn't rely on pre-written list of known issues. It uses logic and understanding, just like a real hacker or code auditor would. And here is something people often misunderstand. Reasoning is what separates AI from automation. Automation just repeats steps. Reasoning allows AI to adapt and investigate intelligently. Now comes the stage 3, which is validate. Once Aardvark suspects something, it doesn't stop there, it actually tests it by building control experiments or sandbox environments. So if it finds a function that looks unsafe, it will try running simulated attacks inside a safe, isolated environment to see if the vulnerability is real. This is huge because in traditional security scanning, you get tons of false positives, like hundreds of warnings that don't actually matter. Aardvark cuts through all that noise by validating whether a bug is really exploitable or not. That means when it gives you a report, you can actually trust that it's something worth fixing. Now comes stage 4, fix and verify. Finally, and this is where Aardvark truly stands out. Once it confirms a bug, it doesn't just say good luck and walk away. It actually proposes a fix. It can generate a patch, modify the vulnerable part of the code, and even retest it to make sure the fix actually works. So it completes the full security cycle: detect, reason, test, and patch. Now let me give you a quick example to make it clear. Let's say you post an update that changes your login or authentication logic. Normally, a human might take hours or days to review that, right? But Aardvark instantly spots that change, test different scenarios, and might even realize, wait, this new login could let users skip verification under certain conditions. It then tells you exactly what's wrong and how to fix it. That's the level of understanding we're talking about. Alright, now the big question, does Aardvark actually work, or is it just another fancy AI concept? Well, here is the thing. It's not theory anymore. OpenAI has already tested Aardvark in the real world, and the results are genuinely impressive. According to OpenAI, Aardvark has already found and responsibly disclosed multiple real security vulnerabilities, and some of them even got assigned official CVE IDs. Now, for those of you who might not know, CVE stands for Common Vulnerabilities and Exposures. Basically, whenever a new security bug is officially recognized as a legitimate threat, it's given a CVE ID so developers and companies can track it and patch it. So the fact that Aardvark's findings made it to that level, that's a big credibility point. And this wasn't just done on test environments. Aardvark has been used internally at OpenAI to check their own infrastructure. Plus, it's been tested on several open source projects to see how it performs in the wild. And it actually caught issues that humans had missed earlier. Things like logic loophole, unsafe API flows, or outdated authentication checks that could have been exploited. Now, one thing I really like, and I think this part is super important, is that Aardvark doesn't operate without human oversight. Every single discovery it makes goes through a human security researcher before anything is disclosed. That ensures two things. Number one is the vulnerability is real, not a false alarm. Number two is it's reported responsibly, so it doesn't end up giving hackers free information. So yeah, OpenAI is being smart about it. They're not just letting the AI run wild and post security issues online. They're combining AI speed with human judgment. And here is a quick pro tip for developers and anyone managing open source repos. Imagine if you could run Aardvark on your own codebase before attackers do. You could literally get a full vulnerability map of your project, find risky code paths, and patch them before anyone else even knows they exist. That's the power of this kind of AI. Proactive defense instead of reactive damage control. Now let's talk about the part that everyone's probably wondering. Isn't an AI that can find security exploits kind of dangerous? That's a fair question. And honestly, it's one of the biggest ethical debates in AI right now. Because yeah, if an AI like Aardvark can hunt vulnerabilities, what's stopping someone from using it to exploit them instead of fixing them? So OpenAI was very aware of this from the beginning. That's why Aardvark was built with what they call a defender-first design, meaning it's designed to operate under controlled, ethical conditions to protect systems, not attack them. Let me explain how that works in simple terms. So first, Aardvark never runs freely on the internet or public servers. Every single action it takes happens inside a sandbox environment. Basically, a completely isolated digital lab where no real damage can happen. So even if it discovers a critical exploit, it can only test it safely within that control space. Second, and this is really important, it always has a human in the loop. That means every finding, every patch, and every test is verified by an actual human security researcher before it goes anywhere near production systems or disclosures. So unlike a rough AI script, Aardvark can't just decide, oh, I found a vulnerability, let me try it live. No, there is always a human approving each step. Third, Aardvark is currently in a private beta and it's only being tested by trusted partners, cybersecurity teams, research institutions, and vetted developers who already have strong complaint systems in place. So random individuals or black hat hackers can't just access it. Now there is also something called the dual use risk. That's the idea that any powerful tool, even one meant for good, can be misused. For example, the same AI that helps defend networks could also, in theory, help someone find weaknesses to exploit. That's why OpenAI's access control and supervision are so strict. The model itself has built-in guardrails. It's not designed to output exploit code or attack payloads unless it's inside that control test environment. So yeah, OpenAI is basically taking a very balanced approach, power with responsibility. And here is a quick pro tip for any companies or developers watching this. If your team ever uses agentic AIs like this, whether it's Aardvark or a future model, always make sure of two things. Number one, run it inside a sandbox, never on live streams. And number two, always do a human code review before automatically applying any AI generated fixes. Because even the smartest AI can misunderstand business logic or introduce subtle side effects that a human might catch instantly. So bottom line, yes, Aardvark is powerful, but OpenAI has put strong safety nets around it. So by now you might be thinking, okay, this sounds amazing, but can I actually use Aardvark? Well, not yet, at least not publicly. Right now, Aardvark is still in a private beta phase, which means only a small group of vetted security researchers and trusted partners have access to it. OpenAI is keeping it that way in purpose because when you are dealing with something this powerful, an AI that can literally find and test vulnerabilities, you don't want to rush it out into open, right? They are making sure everything is stable, safe, and ethically handled before it's released more widely. There is no public sign-up, and OpenAI hasn't announced any pricing or release date yet. But they have hinted that once Aardvark passes all its safety and performance checks, it will likely be integrated into the broader OpenAI developer ecosystem, maybe as part of GPT Enterprise or an advanced security suite for developers and organizations. Now, if you have been following OpenAI's pattern, like how they slowly rolled out advanced tools, for example GPTs, Code Interrupter, or Shora for trusted creators first, this fits that same strategy. They start with a controlled group, refine the model based on real-world feedback, and only then scale it out safely. And honestly, that's the right move. You want this kind of tool to go through serious testing before the public gets their hands on it. Because even a tiny error or misused feature in something like this could cause huge issues if not handled properly. Now here is a quick tip, especially for anyone watching who is into cybersecurity, DevSecOps, or AI research. Start experimenting with AI-assisted workflows now. Even if you can't use Aardvark yet, you can still build the habits, like automating your code reviews, setting up sandbox test environments, or using GPT models to reason through security logic. Because trust me, Aardvark is just the beginning. We're entering a new phase where AI isn't just writing or debugging code, it's actively protecting it. And when this kind of agent tech becomes mainstream, the people who already understand how to collaborate with AI tools will be way ahead of the curve. So yeah, for now, Aardvark is behind closed doors, but it's evolving fast. And if OpenAI's track record is anything to go by, it won't stay private for long. Once it's fully verified for stability, safety, and complaints, we can probably expect it to show up as part of the GPT-5 developer suite or a security-focused API. And when that happens, it could completely redefine how we think about cybersecurity. Not as a reactive game of patches and firewalls, but as a proactive, AI-generated defense system. So that's Aardvark. But now I want to hear from you. Would you trust an AI like this to secure your own codebase? Or do you still feel that humans should always stay in control when it comes to critical security decisions? Drop your thoughts in the comments. I will be reading everyone. And hey, if you found this breakdown useful, you will definitely want to check out my video on OpenAI's GPT-OSS safeguard. It's another major step in AI safety, but this time focused on open source model security. I will link that right here. Go watch that next to see how OpenAI is building a full ecosystem of self-defending AI tools.